Hello, the internet. Welcome to Open Source Directions, hosted by OpenTeams, the webinar that brings you all the news about the future of your favorite open source projects. My name is Madigan Monk. I'm a postdoc at the University of Illinois at Urbana-Champaign. I work on the YT project, and I'm based in Urbana, Illinois. I'll be your host this week for Open Source Directions. Co-hosting with me today is...
Hi there, everybody. My name is Henry Badgery, and I'm the growth marketer at OpenTeams. I'm very excited to be co-hosting this episode. I've just recently moved from Sydney to Austin, and I'm loving it. While I'm in isolation, I'm still loving it. And Wes?
Hi, I'm Wes. I'm one of the founders of the Aero project, and have been involved with it since still active in it nowadays. I have an open source development lab called Ursa Labs, and we work on the Apache Arrow project. And most people know me as the creator of the Python Pandas project and the author of the book Python for Data Analysis.
And hello, my name is Jacques. I am CTO and co-founder of Dromio. I'm also one of the original founders of the project along with Wes in Aero. Actively use it extensively in sort of day-to-day and focus a lot on development of certain portions of the library. It's nice to meet you all.
Yeah, thanks for joining us today. We're really excited to get to talk a little bit about the Aero project. Before we jump into the project itself, let's do our famous visualization of the week section. So we're going to talk a little bit about a viz or some viz-inspired thing that we've been enjoying over the past week. How about first, Jacques, I think you have something to share on both your and Wes's behalf. Is that right?
That's right. So one of the things that I think we're all experiencing right now is a challenge to understand exactly what's going on in terms of data related to COVID. And so I feel like there's a lot of different people talking about things, but not enough data being shown and sort of being presented in a reasonable way. And so the first thing that I'd like to just quickly share is this chart, which describes confirmed cases of COVID by country once a country has at least 100 cases, and the progression day by day over the course of time. And one of the things you'll see is that while the growth is high across many different countries, the key difference to this chart versus other charts is that this chart is normalized by country population. And so I think that everybody starts to look at these numbers in absolute terms, and they see United States leading the pack. And while we all agree that that's a concerning thing, I think that what gets lost in that is that you really have to normalize these numbers by country population. And so we are definitely in the upper third of sort of the number of cases per population, but we are definitely not leading the world in that. So it's just a little bit of sort of perspective, I think, on the numbers. And I think the same thing is true when you look at it state by state. People look at the absolute numbers in New York, but I think people sometimes lose track of the fact that New York is also a fairly populous state. And so while the numbers are severe, there's a lot of other states that are suffering just as much or nearly as much, but probably don't have as large of numbers total because of the fact that they're just lower populous states. So anyway, I think it's just one of those things to always keep these numbers in mind and keep them sort of contextualized, because I think that frequently it's very easy to sort of get misled or get fearful based on certain numbers, but realizing that actually the trends are pretty common across a lot of different regions, I think kind of makes us feel like, okay, things are maybe more average than we think they are, with all of the media sort of talking a lot about absolute numbers.
Awesome. Yeah, thank you for that. I'm sort of got something to share similar to what you shared, but it's in relation to COVID. And it's just one of those videos which shows the change in data over time. And I thought it was quite interesting how you can see South Korea at the beginning had so many cases, and then they ended up dealing with it very, very well. And it's interesting to see that just the US, just looking back and seeing 2nd of March, it feels like an eternity ago. But things have completely changed, turned on its head. And I think that video that I shared expresses that very well.
Excellent, thank you. Okay, so mine is a little different than both of yours. I have really been enjoying listening to synthwave music over the past couple of weeks, specifically like Carpenter Brute, like very synth-heavy, 80s inspired. And so I have linked to two different blog posts of doing sort of 80s inspired plotting in Matplotlib. The first one is recreating the like animation of the sun with like the grid sort of ground moving. So somebody did an animation of this in Matplotlib. It's really cool and fun. So you can see that progress to doing that, how they did it, and then see the source code. And then the second blog post is just doing some kind of cool like neon line plotting in Matplotlib. So enjoy. You can do all sorts of cool synth-wavy plots now, maybe even with some COVID data.
So it's just as serious as Henry and my
yes, very, actually the most serious, I think. So, you know, it's a really good way to present your data. Everybody will take you very seriously. So, yeah, definitely. Okay, so now let's jump a little bit into the Aero project. Apache Arrow is a cross-language development platform for in-memory data. It supports zero-copy streaming messaging and has support for a number of languages, including, among others, C, C++, Python, R, Rust, and again, a lot of others that I'm sure we'll end up talking about a little bit later in this webinar. It has 5,300 stars on GitHub and an amazing 1,300 forks. And it has about 6 million downloads a month just in Python. But as I mentioned before, there's a lot of different language support. And so that statistic is a little misleading, considering that we have a lot of other languages that, that the Aero project supports.
So we've seen how popular this project is, and it's amazing just when I was doing a lot of research. So why was the project started, and what needs does it fill?
Well, I think, Wes, you want to cover a little bit sort of, I think that Wes has a nice analogy of how it got started, because it was kind of, Wes and I think, got connected through a similar interest. But Wes, maybe you can give a quick overview of that.
Yeah, so it arose. I mean, there were a number of different groups that all like converged on this particular problem, which is that we didn't have a common data layer for tabular data that could be used portably across programming languages and different kinds of processing runtimes. So whenever you wanted to exchange a large amount of data between two different computational systems, you had to figure out how to serialize the data and move it between from one point to another. So I think one motivation that we had was to eliminate that serialization overhead and to be able to move the data more freely between processing components in memory, but also processing components between processes. It's like different processes on your machine. And we said, you know, if we're going to do that, we might as well make the data format suitable for processing. So you don't want to you know, move data around in one format and have a different format as the basis for all of your algorithms. So we set out initially to design a data format that's suitable for high performance analytics. So basically structured tabular data processing, but that could also solve the you know, heterogeneous system data movement problem that we were all experiencing in many different contexts.
Yeah, I think that the key thing that is just sort of reinforced that Wes said is that I think that the breakthrough that Wes and I both had, along with the other members of the community, was that if you're trying to think about transport, you will typically come up with a certain sort of dynamic for how you're going to communicate things. And you think about a lot about compatibility and a lot about, you know, the size of the transport. But the reality is that you have to kind of look at the whole picture. And so once you start to realize that you can make transport highly efficient, but if the boundary into the transport layer is very expensive, then it doesn't really matter if the transport is efficient. And so it was this sort of, I think, a breakthrough that if you make a really good format for processing purposes, that is a foundational primitive that people can use in many different systems, then all of a sudden, when those systems want to communicate data, they can communicate it in that same format. And so you remove that sort of serialization boundary. And so it's this kind of unexpected sort of approach to transport, I think, that led us to, hey, we need to have something that's much broader in terms of processing plus transport.
Okay, cool. Thank you. I'd like to say to our listeners right now also, as we're going through and talking a little bit about the Aero project, as you have questions, please post them in the chat and we'll ask them later in the Q&A section. Can you explain the history of the name and the logo of the project?
Well, I think that if I recall correctly, when we decided, so Wes and I started talking about Aero probably about 6 or 8 months before it actually became a project, and we started talking with others and trying to see whether other people were interested in this. And as part of all of this, we decided that the best way to formulate the project was to try to propose it as a new top-level project inside of Apache Foundation. As part of that, one of the feedbacks from the foundation is that we needed to have a formal name. So we actually went through, and if you go out there on the internet, you could still find it probably. We basically did an online sort of voting process among all the people who were going to formulate the project to come up with a name. So I don't remember the exact other names that were close seconds, but Aero ultimately won. In terms of the logo, I think that was very ad hoc. I think that there was a need to have some kind of logo. And so I don't remember who decided that, hey, maybe we could just grab a couple of chevrons and stick them on a slide. But I think that was it. And then that has kind of just stuck. I don't know if Wes, you had anything to add there?
Yeah, no, I remember in the naming of the project that there was a period of time where we had like maybe 20 or so proposed names, and nobody was particularly excited about any of them. And I think somebody proposed Aero, and it was kind of, everyone was like, okay, like that's the thing. And so it I think it won the vote by a landslide.
Yeah, I think that's pretty commonplace in the open source industry that the logo is sort of a second thought and isn't something that people focus on, yet it's kept throughout the entire history of the project. So it's quite funny, some of the logos out there.
Well, the nice thing about the Aero logo specifically is that if you ever need to make it, you can just make it by hand, given its simplicity.
Sketched out, exactly. So are there any alternative projects out there?
Not really. And that's actually been one of the challenges for the project, is that because it occupies effectively a new category of tools, that it's it's different things to different people. So for some people, it's a middleware technology that's just about moving data around, transferring data between systems. Whereas for others, it's the basis of building a processing framework. And so you see, I think people often draw comparisons to serialization tools like protocol buffers, flat buffers, Thrift, and also file formats, things like Parquet, Aero. But it really isn't like any of those, because the purpose of the technology is, as Jacques was saying earlier, is significantly beyond purely serialization and storage and data movement. It's more about kind of a format that can be used in many different contexts without any translation.
Yeah, you talked a little bit about how it builds off of, it connects different languages and different packages, right? So can you tell us a little bit about what technology it's built on and what you use when you're writing it and stuff like that?
Yeah, so I think that the number one thing to start with Aero is that Aero is not, I wouldn't describe it as, I guess I would say that I don't think of it as much as a technology, because I think of a technology, and maybe this is just me, but I think of a technology as very much tied to an implementation. And so the core of Aero is a specification for how memory gets laid out, how data gets laid out in memory to a standard sort of structure. And then inside of the Aero project, there are many different implementations. So I think that we're around 15 different languages with different implementations of how to interact with that set of structures. And you can interact and use those structures for many different reasons. And so one way to kind of think about it is that the specification is, this is going to be a bad analogy because I'm good at bad analogies. But you could think of the specification as something like a hash table. So a hash table, the concept, is independent of any particular implementation of a hash table. But the concept is kind of this abstract algorithmic concept. And I think that Aero is a little the same way. And so there's many different ways that you can use it, and many different problems that it solves for different sort of scenarios. And then we build a bunch of tools around how you might use it. But at its core, it's, hey, how do we express data in a standardized way? But then you layer things on top of that, like transport and whatnot. So as I said, there's many different languages and implementations of how to work with it that are all within the Aero project. But at its core, it's this simple concept of like, hey, how do we express data in a standardized way?
Okay, that's great. Yeah, thank you. So you sort of touched on the history of it. You talked about logo and its origins. So who actually maintains, or who started the project?
There were about a group of about 25 people who were part of the original project. Maybe 20 people who were part of the original project management committee. And maybe I was not it was my first time being involved in an Apache project. So I wasn't on the PMC because I had no Apache karma at the time, but there were about 25 of us. And so we were like the group that we all signed our name and said, we approve of this project and we want to see it, made a reality. Since then, the developer community has grown and we now have about 50 people with commit rights on the project. And so they're kind of the 50 or so committers are the gatekeepers of code going into the project and overseeing the maintenance, release management, packaging, and all of the day-to-day operations of the project. So I think we're up to around 30 members of the PMC. So we've added 10 or 12 PMC members, which are kind of the voting, kind of the formal governance committee of the project. But in terms of people who are really active maintaining the project, there's a core group of maybe, I don't know the exact number, maybe 7 to 10 people who are, really active day to day and reviewing code, merging patches, keeping an eye on packaging issues, dealing with all of the day-to-day work that happens around making releases and maintaining, keeping an eye on, triaging bug reports and so forth.
Yeah, and I think the other thing to hit on there is that one of the key things that core group also does is work with all the contributors. So as Wes mentioned, I think that there's something like 50 committers at this point, but I think that there's been contributions by somewhere close to 400 different people. And so there's been a lot of different people who have been contributing to the project, but those core sort of people are the ones that make sure that those contributions are of the appropriate quality and figuring out how to shape those to get those into the code base.
That's an impressive range of committers that you have in your project. Over 400 unique contributors is amazing. That's really a very healthy metric for your project. That's really nice.
I think that one of the things that helps drive that is the fact that there are so many different languages in the project. And so it means that, I think that one of the things that sometimes happens with open source projects and contributions to them is that if you are not working in the language that project is in, it's very hard for you to figure out how to engage in the project. And because there are so many different languages in the project, that generally speaking, most developers that encounter the project can probably contribute to it. And I think that combined with a very sort of, open culture in the community to accepting new people and trying to get them engaged and helping them be successful, I think that those two things, have helped that number grow.
Yeah, I think one of the things that's really interesting is some of the kinds of collaborations that have happened. So, for example, there's a group of very active contributors and maintainers in the project who are part of the Ruby community and are based in Japan. And so the fact that somebody like me, who's really a Python-centric person, have active collaborations with the Japanese Ruby community, and we have common code that we're depending on and we're maintaining together, has been really exciting and interesting because, traditionally, you just wouldn't really see cross-pollination between these communities. And even between the Python and R community, you would see very little collaboration, but yet, as we have this shared interest and that we all depend on the C++ code base in the Aero project. And so, that sort of kind of fosters that kind of contributor and community growth because there's a sense of shared ownership over these pieces of software that we depend on.
Yeah, that makes a lot of sense. So do you see, I'm very curious, because you've kind of talked about this Ruby community, what other communities do you see users and contributors coming from? Is it specifically language, or do you see very specific application communities that are involved in the project as well?
Well, one of the things that we probably didn't say so far, maybe you said it in your intro about Aero, but we're primarily focused on data and analytics. Mm-hmm. Like that. So generally speaking, all of the communities are focused on that set of problems, right? The shape of why this is a useful tool is because of it allows you to process large amounts of data very efficiently, very quickly. And so all of the communities, I think, share that interest. Now, it may be in different contexts. It may be a single node, like large single node, single tenant workloads. It may be massively parallel multi-tenant workloads. It may be workloads that are more in the front end and inside of a browser than it is in the back end. And so there's different places where it can be applied to analytics, but they all share that same sort of interest in data and analytics.
Yeah, so it's sort of, I would describe the community as being a mixture of people from the analytic database world, so people like Jacques, and people from the data science kind of data frame, side of the world, so people like me. But we also, I think it's been interesting to see the growth of new languages. So, for example, Rust has become more and more popular language, and so we, organically, at some point, some Rust developers showed up and said, we want Aero for Rust. And so now we have, a pretty active group of Rust developers working in the project. And, and they work somewhat independently of the rest of us because Rust is a world unto itself.
Mm-hmm.
It's great to hear. It's great to see that you've got such a diverse range of contributors. And 400, that's very impressive. So kudos to you and your team. So is there any official participation in diversity and inclusion efforts?
I think one of the things we've done, we've held a number of, or people in the community have organized a number of hackathons or sprints for the project. So, like, I know that there've been a couple of them in London. So Kohei Suto in Japan has organized sprints or meetups for Aero to kind of help people get engaged in the project. And I think one of the biggest things with with diversity and inclusion is helping people get themselves oriented in the project, get their environment set up, and getting them to the point where they can make their first contribution to the project, no matter how big or small. And I think that the culture of the community is very open and collegial, and so I think we maintain a very positive tone. We have a code of conduct, so I think it's not a place really for strong words. Occasionally we have some intense disagreements, but it's I think there's a very strong feeling of like we're kind of working for the common good, and it's I think that's very important for fostering an environment that can grow more diverse and inclusive.
And I think that the other thing, which maybe doesn't exactly answer your question, but I think that one of the other things that I was very passionate about, I think Wes and I think shared that perspective a lot, was that there are different kinds of open source projects. I think that there are a lot of open source projects that are primarily driven by one company, and that one company basically controls the project, okay? And says this is what the project is and this is what it isn't. And if you want to, and so they're kind of dictatorial in nature. And they may be even in some of the foundations, which suggest that they're not, but the reality is that they really are. And I think that one of the things that it was super important to me was to have a project that was that brought a large group of different types of people together to begin with, so that we didn't have that. And so I think that even if you look at the original makeup of the project and the 25 people or whatever it was that we started with, they were from many different companies with many different kinds of backgrounds. And I think that that's really been a goal of the project since the get-go, is something that's very much consensus driven, that has a lot of different personas, profiles, personalities that are all kind of working together. And so that, I think, is a way to drive a more diverse community, because then other people can observe that and recognize that it's different. I think that, Wes just mentioned this sort of dynamic, which is that really, if you think about it, there is kind of been this two different worlds in data, one being sort of more the data science side and one more the sort of database side. And there aren't a lot of communities that have those two types of personas working together, because they come at it, somewhat differently. But I think that when you start to have that, I think that the diversity of idea, I think, gets much stronger. So I think that's something we've done well.
That's great to hear. Yeah, I'm going to post now in the chat just a blog that Travis Oliphant wrote. It basically distinguishes between company-backed open source, which he defined it as what you talked about, and also community-driven open source, and some of the advantages and disadvantages of both. So I think that's an interesting read for everyone watching.
Yeah, well, thank you to both of you for giving us a good intro to the Aero project. So now I think we're going to shift into the project demo, where we'll get to see some of the cool features of Aero and how it works. And while Wes is getting set up here, we'd like to take this opportunity to thank our sponsor, Quantsite, for sponsoring this episode of Open Source Directions. Quantsite, creating value from data. So when you're ready, Wes, take it away.
All right, so application window. All right.
Live demos during COVID.
Oh, yeah. All right, so so just very quick demo where I'm going to show just importing a few libraries that we're familiar with: NumPy, Pandas, importing the Apache Arrow library, PyArrow, in the Jupyter Notebook. So I'm going to use the PyArrow library to read a Parquet file, which and here's the schema. So this is like the general structure of a so you have column names and types. So now after loading that file, we can see, as we track all of the memory that's allocated, we have around 360 megabytes of memory allocated. One of the features that is very important in the project is the concept of memory mapping and being able to work with large data sets without having to load all of the data into memory. So we have a binary protocol for Aero data where we can put data on disk, or we can send data over a TCP socket or whatever. So I'm going to write 50 copies of this 300 some megabyte table. Hopefully my video will start doing computation when you're also doing a demo. I just created about a 9 gigabyte file on disk that contains 50 copies of that table end to end. And so I can memory map that file and then open the file with the IPC OpenStream function. And then I can quote unquote read the data into memory in about 3 milliseconds. And so that doesn't actually read the data. And so it has, let's see, 50 million rows. But because this operation is just moving around memory pointers, it doesn't actually change the amount of allocated memory. But still, I have an object where I can do analytics on it. So if I select a column like the number 2 column, it's this chunked array object, and then I can call functions like unique on it.
I think we may have lost Wes.
Oh no.
His computer has failed.
Yes, apparently. So I can give a brief overview of what I think he was trying to show, which is that by memory mapping the data, in his example, he had 9 gigabytes of data. By memory mapping that, you can have virtual memory access to that data, and then rely on the kernel to decide what data is actually pulled into memory versus what stays on disk. And so even if there are, say, 25 columns in this data set or whatever it was, his interaction in this example with the unique set of names was interacting with one of those 20 columns. And so the system can very efficiently pull that data into memory, do the distinct count on it, and return those distinct records without actually ever pulling the rest of that data off of disk. So it's a nice way to interact with very large data sets without having to constantly pull all the data into memory.
All right, I'm back. Sorry about that. I guess
Ah.
doing a lot of computation has a way of nuking your computer. So I'll try again. Hopefully this won't destroy my internet connection again.
Well, you have a great co-joiner with Jacques who definitely backed you up.
Yeah.
So
quickly jumped on. Very sweet.
So there's another part of the project. I don't know if you probably lost me before I got to this, but there's another part of the project called Flight, which is a framework for building high performance data services. And so our idea with Flight is that we wanted to make it really easy for people to add essentially an Aero based data service for sending and receiving large amounts of data over TCP. So you can use Aero to move around large data sets in a network. So it's built on top of gRPC, which you look up. It's a data transport and remote procedure call framework from Google. So you can, I don't have time to go into the details, but you can implement both a Flight client and server. In Python, I'm going to spin up an example server, kind of Martha Stewart a little bit. And I'm going to load a large data set and copy it 10 times in memory. So I'll show you how big the data set is. So it's 1.8, let's see, 1.8 gigabytes or so. And so I'm going to send that data set over TCP from my client to the server, so using Flight. And so I'm able to send about 1.7, 1.8 gigabytes of data via Flight over TCP in 1 second. So that's almost 2 gigabytes a second over TCP. And so one of the transformative things about Aero for moving around these data sets is that neither the client nor the server need to do any serialization. So we essentially put the bytes directly over TCP, using gRPC. And on the receiver side, there's no translation or serialization that's necessary. So literally, you're looking at what will limit the speed of your transport is how fast your network is. So similarly, I can request the data back from the server, and it takes about a second. So so kind of one of those things that once you've built this stack of technology that works works well together like that. I'll stop sharing my screen. Then you can do this very fast data transport. And I think one of the things that's cool about Flight was that it was co-developed with the Java implementation of Flight. And so there's a very active, kind of mature Java code base and people using the Java library in many different contexts. And so you could have a Java-based server or a Python-based server, and they can send these data sets to each other at very high speeds. And so we wanted to kind of enable that kind of fast cross-language data movement.
Yeah, to give you some sense on that, and I don't have the slide in front of me, but one of the things we like to demo sometimes around that is that so I work at Dromio, and we're somewhat like a distributed database for data lakes. And one of the things that's really important is being able to return data very, very quickly. And so we started to experiment with Flight. And so for some of our example scenarios, we see between a 20 and 50x improvement in performance of moving data from the servers to the clients. And so it's always a fun thing to demo. I didn't demo it here, but I think that the numbers that you're seeing from Wes's demo, I think, are indicative of the kind of thing that we can do.
Yeah, I think a very common thing that people experience, especially in large companies, is that they're requesting all of their data is coming to them over either JDBC or ODBC, and so you have these pretty kind of very old, like ODBC has been around for a long time, but relatively inefficient database protocols. And so the way I think about it is you're trying to drink a thick milkshake through a straw that's too small, and so it's pretty unsatisfying that you're kind of trying to load a large data set from a database and it's coming through a pretty narrow bandwidth connection. And so it's our goal to build something that could be used to replace things like ODBC to deliver data much more quickly from the places where it's stored.
This is amazing. And also the fact that you can transfer this between languages, I mean, that makes it like, I don't know, I've spent so much time doing kind of cross-language data passing with serialization and deserialization. It's so annoying to be having to do that. So yeah, that's amazing. It must be.
Yeah, I mean, I think one of the things to, also to keep in mind is that, the project's focus is really on structured tabular data sets. So things like data frames. And so, sometimes, we do talk to people, especially people working with things like TensorFlow or doing scientific computing on tensors. And so, it's almost like a different world in that, the kinds of data that is being worked with in analytic databases, which effectively things like JSON, so CSV files. So it's a slightly different beast. And so I think whenever we talk about general data transport, I think we have to remind, kind of frame the discussion around tabular data, effectively database tables. Like that's the primitive in Aero is effectively, the database table concept.
Yeah. Do you codify this in a schema for people who are building new support for like new sort of data types or something like that?
Yeah, so I think you kind of break it into two different pieces. So Aero has a specification to express a number of different data types. I think there's probably 20 or something like that. And that includes arbitrarily complex things and unions and lists of things and those kinds of concepts. And then every time two systems are communicating Aero data, they first do basically a handshake, which communicates schema information between the systems so that they can understand what the other person is going to be sending or receiving.
Okay. Cool. Awesome. Well, thank you for this demo and answering these couple of questions. Now we're going to go into the roadmap where we're talking about the future and where the project is going. So new features or new initiatives or things like that. And again, I'd like to remind all of our listeners to please ask questions in the questions or the chat, and we'll ask them right after this section is done. So Wes and Jacques, where is Aero going? What can we expect going forward?
Well, one of the things I'd love to share quickly is I actually have this slide that we can talk about this ahead of time, but I have a slide that I like to show that kind of gives a little bit of a narrative of where we're at. I think that it's sort of a good place to start. So let me just share that quickly.
Yeah, that's great.
Let me see if I can figure out how to share it here. All right. This is a slide that I like to talk about, it's all kind of approximate. Like it's not exactly right, but it's kind of a bunch of directions that we've been going. And so building up an open source stack, which is what I kind of think of Aero as, has been sort of many different steps. And so what you can see here is that we started out and basically at the beginning of the project, we were just about building a community of people who had like minds and were trying to figure out how they could work together on stuff. Once we had that, then we started to formalize the Aero, what we call the Aero format, which is how we structured these things. And we had some initial sort of, sketches of how we wanted this to work, but really had to sort of rework those things based on new ideas and inputs by different people in the community. Once we did that, then what happened was an explosion of language bindings. So as I mentioned, somewhere between 10 and 15 different language bindings now, different ways to interact with Aero. And so we kind of layered those things on. After that, one of the things that was a really sort of easy killer app, or not easy in terms of implementation, but something that was easy to get adopted, was a high quality file format integrations. And one of the ones that's probably the one that draws the most engagement into Aero today is the work that Wes and others did on a Parquet reader and writer for Aero. And so a natural place that people worked was that one of the things that happens is that you have these file formats that different systems want to interact with. And the file formats are theoretically very efficient to store data, but then frequently the libraries that are implementations that are designed for pulling the data out work through what I describe as cell level interfaces. And so if you're trying to read, say, a Parquet file, and you read, take an existing library or the first set of libraries before Aero existed, and imagine it's a million records with 10 columns each. And so that's 10 million cells, right? So it's just rows times columns, simple version of this, right? In traditional interfaces, that's in order to read that data, you have to invoke a method for every single cell, at least one method, potentially more than one. And that just creates a huge amount of inefficiency in how you move data from something like a file format to an in-memory format. And so the sort of natural thing to do was in Arrow's case is to be able to break down that boundary by basically moving all of the stuff into memory without having and exposing it in a way that another tool could consume it without having to do that sort of cell by cell transfer. Once that happened, then we started working on things that we call execution kernels, which are different sort of modules that know how to process Aero for a particular purpose, right? And so one of the ones that we worked on at Dromio was one called Gandiva. There's a bunch of others in terms of like identifying distinct values, putting things into dictionaries, putting things into a hash table. So there are different tools to work with the memory format for a particular application, okay? And then we said, okay, once we have these tools in place, let's start to support transport. And so we've always been able to move Aero data around, but moving it between different systems over TCP was something that was kind of done more sort of bespoke for each system. And so Aero Flight, which we introduced about 1.5 years ago, I guess, and has been getting a lot of sort of more adoption more recently, was the next thing. And so that's kind of how we got to where we are. Every single one of these things is a key part of development. I think that so that's kind of to give you a bit of a background on this, and then maybe Wes, you could talk a little bit more about sort of a lot more about where we're going.
Yeah. I think there's a couple of different themes in the overall development of the roadmap. So one area is broadening language support, and so we're active about recruiting new people into the community. So trying to look for people who are interested in either building new bindings, so from one language to one of the other implementations. So like, it's relatively straightforward to build bindings for the C++ library. And so some languages can get access to a lot of Aero functionality by doing that. Mm-hmm. Others want to create new native implementations. So like the Rust implementation is an example of a new native implementation. Another area of work that we're doing is making it easier for projects to implement a little bit of Aero and for them to export and import the subset of Aero that they support into another project that supports Aero. And so we recently created and adopted a C-based data interface for systems to essentially implement Aero, but they can implement as large or small of a subset as they wish, and they can do so without taking on no new code dependencies. But essentially, they copy a tiny C header file into their project, and they can provide essentially they can export an Aero array, an Aero batch at C call sites, and so that's something we're going to be talking more about on our blogs and so forth. Within the different language implementations, some of the libraries are more purely about data handling, memory management, and providing kind of access to the data. And so I would describe the Java library as being, more strictly concerned with the implementing the memory layout. There's a flight implementation for Java. There's an implementation of the binary protocols. But in terms of where there's a significant analytics and query processing, essentially database style processing, a lot of that's happening in other projects like Dromio. So where you have more like proper databases that are Aero based. However, there's, as Jacques mentioned, Gandiva, which is a kind of kernel, execution kernel for Aero based on Llvm. That's accessible through Java as well. Within, in particular right now, the Rust and C++ libraries, one of the big initiatives is building out proper query engines. So basically, if you think about like the guts of an analytic SQL database, so the ability to do aggregations, filters, joins, column expressions, the sorting, like the essential relational operators for, you can think of them interchangeably as either the things you would do in SQL in analytic databases or the things that you would do in data frame libraries. And so there's efforts both in Rust and in C++ independently to build proper query processing systems. And so that's what, for example, myself and my team, that we've been working towards that for the last couple of years, kind of laying the foundational pieces of being able to execute, high performance, parallel, filters, aggregations, joins, group by operations, kind of the essential stuff of database systems. But I think the particular interest for us is to have effectively a database system that can be embedded in languages like Python and R to give a lot higher performance analytics for those languages. And so if you think about kind of the relationship to database systems, people building analytic databases have created very advanced query processing tools over the last 25 or 30 years, but relatively little of that intellectual that intellectual heritage from the analytic database world has made its way into the hands of data scientists. And so usually people access that functionality by writing SQL queries and sending them off to a database. And so we want that same kind of power, kind of the query compilation, the Llvm code generation, things that Gandiva is doing, and the kind of the architecture of analytic databases to be available in a library that can be shipped and deployed in Python applications and R applications. So it's obviously a very big project and one that will take many years to fully realize. But I think the kind of mantra of the Aero project is that it's a reusable toolbox of components. So you can come and use the components that you need, and so it's different things to different people. So some people won't use any of the query processing components at all, and they just want to transport data, and that's totally fine. And so they can ignore the they just don't have to build the analytical components in the project.
And I think that the thing to remember is, as Wes is talking about all of these things, is that because a core component of Aero is the cross-language support, if you're looking at Aero for a particular use case, and you discover, for example, Russ was mentioning that there's query engine capabilities and execution kernels in the Rust library, and you may be writing something that has no Rust in it, you don't know anything about Rust. The reality is that the way that these things have been composed allows you to tap into languages that you may not otherwise have access to, because you can move very efficiently between them. And so to give you some sense on that, so as Wes mentioned, one of the projects we worked on, this piece of Aero called Gandiva, is an Llvm based compiler for low-level query expression evaluation. And we implement that in Llvm because it's a very strong platform for that. And a lot of databases have done the same thing using Llvm. But what's interesting for us is that a lot of our work is actually done in Java. And what we were able to do because of Aero was to be able to effectively farm out this kind of processing for a particular into another language, and take advantage of the strengths of that language, while still working with it in working with a lot of other stuff in a different language. And so just because something might be implemented in Aero project in a language that's not comfortable to you as a developer, doesn't mean that it isn't something that you could leverage and benefit from.
Yeah. And so I will also say that there's a lot of really interesting Aero-related work that's happening outside of the Apache project. So, for example, you may have heard of the NVIDIA Rapids project, which is NVIDIA's GPU analytics initiative. That's all Aero-based. So you have people, building Aero-based applications or Aero-based systems, on the outside. And so, I think one of the things that we want to do is we want to make sure that the core Aero project and libraries are supporting the growth of applications that are Aero based, and so we see their success as our success and vice versa.
Yeah, absolutely. I mean, a couple of other ones that you guys may not know about is that Google also started offering a Aero integration for some of their technologies. And I think that Microsoft is also working on something in that realm. And so
Amazon also does. So
that's right. Amazon as well. Yes, good point. Yeah. And so what you're seeing is that which frankly it's pretty cool. Like for us to come together is and sort of push something that now the major cloud providers are all starting to adopt and sort of adapt their platform for. Because they're seeing the benefits as well. And so, to Wes's comment, the goal for Aero is to make us work together on this data It doesn't necessarily mean that every single person who's working with Aero is necessarily contributing to the core project. But making these things work together against that specification is a key part of success.
Yeah, nice. Okay, well, I'm gonna not ask any questions because I think we don't have too much time. So let's jump straight into the user questions instead. Henry, do you want to ask the first one?
Yes. So this is a question from Mustafa, who's joined us from France. Hello, Mustafa. Welcome. And he'd like to know how can he contribute and how can he follow both of you in the project?
Well, I think we're both on Twitter. Wes is far more prolific than I am. I think he has 500 times as many followers and tweets, maybe 5,000. I don't know. And I think we can post that contact. It's pretty easy to find us. I would say that in terms of the project, I would say the best way to contribute from my perspective is to find something that you're trying to solve, and then ask how you can use Aero to do it. I think that arbitrary contribution is very hard because it's not really driven towards a particular goal. So I'd say, like, look at how you can use it. Now, I think that one of the places where people often see something early that they could really contribute to, but they don't necessarily recognize it, is that one of the first things that people experiencing when working with a new project is the documentation, the examples, and sort of getting up to speed on how to use the project. And so an early contribution that's usually a pretty easy one for people to do is to identify things that either could be improved or small pieces of new content that you would think would help the next person who comes along. That's a good way to sort of start getting engaged. But we also, I think, have a bunch of smaller bugs that people could pick up and things like that as well.
Do you have any particular places in the documentation that you feel could be improved? Like, based on your experience?
I mean, 1,000 places, but I'd say
all of us.
That's most open source projects.
Yeah. The top one for me is more examples of how to use it.
Okay.
Like, I think that most developers respond very positively to a real use, an example. And as they're trying to solve problems, if they can see how someone else has solved similar problems, it's very helpful. And I think that we have some examples, but I think that we have far less than we could have. So, for example, we've talked about integration between different languages, but I don't think we have a sample for integration between most languages. So if you could do an example of, hey, here's how to move data between Aero in language X versus language Y. And move those back and forth. I think that would be great as a place to sort of show people how to use stuff. I think also samples, the simple samples like the one that Wes was just sharing, right? Which is like, hey, here's a 10-line example of how to use Flight, or here's a 10-line example of how to use Gandiva or whatever. Those things can really sort of jumpstart someone to make progress.
Yeah, and then also it's more inclusive, right, for somebody to come and join too. So that's really nice. Our next question is from Peru, who asks, what would be the coolest feature in Aero that's not implemented yet?
I mean, I guess I'm excited about building query processing components. So I'll be excited to see hash aggregation, so like grouped aggregations and joins implemented. So I think those will be two exciting milestones when we have high quality implementations of group by operations available. And I think one of the cool things about it is that, in working on this, we're kind of going to be earning like mini PhDs in database systems. So you can watch Andy Pavlo at CMU. He's got great lectures about building database systems. And so, I think we really want to make sure that we're building stuff that is consistent with the state of the art in the analytic database world. We aren't really reinventing any wheels. So I think we just want to build high quality, reusable implementations of these kind of standard, relational database type operators. And those can be, people will still be using this code in 10 years. And so to be building kind of this critical data processing code that we can use for a generation is, for me, it's just very exciting.
Yeah. So the other thing I'd say, because I agree with Wes. I think that cool is an interesting question. Is an interesting adjective. As an engineer, the coolest things to me are the things which are in some ways the hardest. most complex, the most mentally challenging. And so if you're using that, like there's other kinds of cool, right? Like, hey, what is the thing that people would use the most or people would log me for or whatever? Those are other ways of cool. But as an engineer, I think of cool as being the things that are most mentally exhausting, if you will, but finding the elegant solution to those things. And so one of the things that I find with Aero, and I think that, Wes, I think you've experienced this as well, is that the algorithms, there's a lot of well-known algorithms for doing things like relational operations in databases, hybrid hash billing, papers, I don't even know how old, 25 years old now, 30 years old. So those things are very, some parts of those are very well known. Where they start to be very interesting and different is when you start to map them to the memory representation of Aero. And you start to get into problems like memory fragmentation, and get into problems of like vectorized or non-vectorized processing for certain operations. So one of the key things about Aero is an in-memory columnar format. And people kind of hear that and they think, yeah, okay, great, whatever. But what it means is that, normally when people think about processing, they think about it in terms of rows. And so I think about a record and how I'm going to deal with this record. And if you think about most of the traditional relational operations and how they're thought up in terms of dealing with records. I'm joining these records with those records, or I'm aggregating these records. But the way that Aero is expressed and how it's laid out in memory is columnar. And so you've got many different records for one column in one chunk of memory, and then many different values for another column in another chunk of memory. And what happens is that as you're working on these operations, as you iterate, you start to realize that you need to reposition some of your operations so that they're much more vectorized. And that's it's an extra level of complexity to building these algorithms. And that, I think, is one of the cooler things to do. And so it's this combination of a complex problem and a target of being highly efficient. And so layering those things together, I think there are lots of specific examples of trying to solve that sort of complexion of problem. But I think that that's the coolest thing to solve in Aero, and there's a lot of places to do it.
Sounds extremely cool, even if the word is ambiguous, for sure. Okay, so now we're going to go into our world famous rant or rave section on whatever topic you feel like ranting or raving about. Since we're running out of time, I'm going to encourage all of us to go, do a short rant or rave, as short as possible. So Wes, why don't you go first, and then Jacques, you can go after.
All right. Yeah. So. Yeah, in the last few months, I've gotten really excited about at-home fermentation. So if you're looking for something you can do that doesn't require you to leave the home, like when you're quarantined, fermented cabbage is an excellent thing. So I highly recommend it, and it will make you healthier. So I'm not a doctor, but I enjoy it.
Healthy gut bacteria, right? That's what that's about.
I'm gonna rave for a very short amount of time about the people I work with and the people I've interacted with. I think that everybody is dealing with a set of circumstances which is new and is challenging. And just like the resiliency of everybody I'm interacting with is pretty cool. And so I'm just gonna say in general, good job to everyone that I interact with, including you guys.
Very nice. So my rant for the week, more maybe a rave, is I've actually used this coronavirus as an excuse to run half a marathon. So I've been training up for that, and I ran the other day the furthest I've ever run, and it was only a measly 3.5 miles. But got to get there.
Start somewhere, yeah.
That's awesome. That's more than a 5K, man.
Yeah. I'm impressed that you're
count it in Ks, man. It goes faster. You make more progress.
Yeah, exactly.
Yeah. I'm also impressed that you're using miles. You really adapted to the Texas lifestyle.
I've had to. Yeah. Everyone be confused when I say Ks.
Yeah, I think these are all positive. So I'm going to end mine with a rant, and it's negative. And I've been wrestling with CI platforms all week, and I feel like it's like whack-a-mole. It's super frustrating. This week we just found out Travis stopped capitalizing job names. We used that to solve some part of our environment, and so all of our tests started failing. So it's great. It's super fun.
So I will say that we very painfully have migrated almost all of Apache Arrow's CI to GitHub Actions, and it has been wonderful.
Okay, pro tip. Yes, I was going to actually ask about your testing because all these languages must be.
Yeah, we actually have one of the largest GitHub Actions configurations that I've seen in an open source project. Like we have maybe around 40 jobs, so it's large and yeah, it's able to keep up quite nicely. So
awesome.
Kudos to Microsoft for offering all that free compute.
Well, thank you for turning my rant into a rave about something else, Wes. This sounds fantastic.
This is the first time I haven't heard. I've heard a lot of rants from Wes on CI, so this is nice to heard the other one.
Yeah. Well, that's all the time we have for today. Thanks for watching and thanks for listening. You can find us on Twitter at OpenTeams Inc. or at Quantsite AI. If you're interested in funding open source projects, including Apache Arrow, you can find all the project roadmaps at quantsite.com/projects. Wes and Jack, I think you talked about your Twitter presence earlier, but where else can we find you and Apache Arrow?
We have an Apache Arrow Twitter. It's not super active, but it's high information content.
Mm-hmm.
And we also have a developer mailing list, so dev@arrow.apache.org, and once you set up some email filters to send all of the Jira notifications into a separate folder, I think it's you might find it interesting to follow along with the development discussions. So that's where we're the most active.
Yeah, and the other thing I'd say is that Wes and I both do a lot of talks. There's a bunch of other people that do as well. So there's a lot of slideshows out there and videos talking about sort of more detail about a bunch of the things that we talked about today. So you can go out and find those things. As Wes mentioned, I work at Dromio, and we built a database kernel all on top of Aero and Gandiva, and that's open source. So you can check that out on our GitHub. So that's Dromio. And that's a bunch of places.
Yeah.
Okay, well, thanks you two, and thanks for joining us. And join us again next episode where we'll go to a discussion on Fortran. Thanks, everybody.
Thanks for joining.